Hi, I'm John Mugen with Wolfspeed, and here we're at the display of our new SpeedFit online simulator. It's a one-of-a-kind simulator for simulating silicon carbide MOSFETs, devices, diodes. So let's take a look at it. So if you look at our homepage, which is wolfspeed.com, there's a link right under Power Products. It's the last link on there, and it's called SpeedFit. Click on that. It's a free tool for designers. So it categorizes circuits for simulation into broad categories. We have DC to DC converters, AC to DC, and DC to AC topologies that can be selected. Let's pick an easy one. Let's pick a DC to DC converter. And let's pick some voltages. Let's say we want a boost converter. Let's go from 400 to 800. And you pick your power level. Right now it's set to 2 kilowatts. You can then select your switching frequency. And being a silicon carbide simulation, I'm going to move this from 20 kilohertz to 200 kilohertz. And let's select the boost converter topology. It displays the topology that it's going to simulate. And if we hit next, it will then show our product library. So all the silicon carbide MOSFETs and diodes that we have in our product portfolio is listed in the product library. It'll make a suggestion as to what you want to use. If you don't like what you see, you can hit show all, and it would show all the devices that we have in the library. Also, next to each one of the devices is a link to the datasheet. So if you wanted to see what the datasheet looked like, you can just click on that icon and it would display the datasheet. So let's pick the device that it suggested, the C2M 25 milliohm MOSFET. You can also adjust the gate resistance of this device, because as you know, gate resistance has an impact on switching losses. So we make that a parameter. You can then select your boost diode. It displays the package that you've selected. You can also parallel devices. You can tell it how many MOSFETs and how many diodes you want to put in parallel. Hit next. And then here we select the cooling mechanism. You can have an individual heatsink for each device that's not isolated, or you can have an isolated heatsink. And you can pick the thermal interface material between the device and the heatsink. You can control that. Let's put in a value of 0.5. And then if you know your heatsink parameters, you can fill that in and it would account for that. Or you can just fix the heatsink temperature to a constant value of, let's say, 85 C. We hit next. And it shows, once again, the circuit that it's about to simulate, along with the value of the passive components, the inductor and the capacitor, and these are also parts or values that a user can change. Okay, then we hit simulate, and in seconds you have the answer. It'll display the total losses in the MOSFET, in the diodes, and the total losses for your system, along with a estimated junction temperature for the diode and the MOSFET. And we have more than 8 topologies in the simulator at this stage. Not just boost, we have buck boost, inverters, single phase, 3-phase. And you also have the option of holding the results that you see and then making a change to your simulation. Right now I'm going to change the boost inductance from 10 milliohms to 5, and I'm going to run the simulation again. Took about 6 seconds to run, and we have the results for the first case, which was at 10 milliohms, and then we have the results for the second case, which was at 5 milliohms, and now you can compare and contrast the changes of the two configurations. And then the last tab is the summary tab, and it will list the 2 different configurations that you selected and simulated and what the results were, and you can print it out on a printer, or you can save it as a PDF, email it to your colleagues. And the last tab on here is the help tab. It has a user guide in there. It tells you how to use the product and answers any questions about how the results are calculated. Okay, so it's a great tool for design. It's very easy to compare the performance of silicon carbide to silicon, and we hope you use it.